You're already familiar with solids like a square, rectangle, cone, sphere, hemisphere, and cylinder. Do you remember their areas and volumes? Now, let us closely look at some of the objects we come across in our daily life. We have all seen trucks like this which have a container fitted and are often used to transport petrol or diesel. Is the container in the shape of any solid we know of? The container of the truck is made up of a combination of solids, that is, a cylinder with two hemispheres fitted at both the ends. Since the container is made up of a cylinder and two hemispheres, the total surface area of the oil container is equal to the sum of the curved surface area of cylinder and the curved surface area of both hemispheres. We know that the curved surface area of hemisphere is 2 pi r square and the curved surface of area of cylinder is equal to 2 pi r h. Substituting these formulas and simplifying, we get total surface area of oil container equal to 2 pi r h plus 2r. Now, using the concept learnt of finding the areas of combined figure, let us solve some real-life problems. A tent is in the shape of a cylinder surmounted by a conical top. If the height and diameter of the cylindrical part are 2.1 meters and 4 meters respectively, and the slant height of conical part is 2.8 centimeters, find the area of the canvas required for making the tent. Also, find the cost of the canvas of the tent at the rate of 500 rupees per meter square. Can you identify the figures that combine to form a tent and how do you determine its area? Here, it is given that cylinder is of a diameter 4 meters, so radius is equal to 2 meters and height of the cylinder is 2.1 meters. A tent is a combination of a cylinder and a cone. So the total area of tent is equal to the sum of the curved surface areas of the cylinder and the cone. Let us consider this as equation 1.
What is the formula to find curved surface area of cylinder?
We know curved surface area of cylinder is equal to 2 pi r h. Substituting the given values of r, h and simplifying, we get curved surface area of the cylinder as equal to 26.4 meters square.
What is the formula to find curved surface area of cone?
We know that curved surface area of cone is equal to pi rl. It is given that for a cone, its slant height OC is equal to 2.8 meters. Substituting the given values and simplifying, we get curved surface area of the cone that is equal to 17.6 meters square. Now, substituting the computed values of curved surface areas of cylinder and cone into equation 1, we get total area of the tent as equal to 44 meters square. It is given that the cost of canvas per meter square is equal to 500 rupees. Then, total cost of canvas for the tent is obtained by multiplying the total area of tent and cost per meter, which is equal to 22,000 rupees. Now, let us find the total surface area of the wooden object. An wooden article is made by scooping out a hemisphere from each end of a cylinder as shown in figure. If the height of one cylinder is 20 centimeters and its base is of radius 3.5 centimeters, find the total surface area of the article. Can you identify the figures that combine to form the wooden object and how you determine its area? Here, it is given that the height of the cylinder OA is equal to 20 centimeters, radius of cylinder OB is equal to 3.5 centimeters, and the radius of hemisphere OA is 3.5 centimeters. Here, the wooden article is made up of a cylinder and two hemispheres. So, its total surface area is the sum of the surface areas of the cylinder and the two hemispheres.
What is the formula to find curved surface area of cylinder and hemisphere?
We know that curved surface area of cylinder is equal to 2 pi r h and that of the hemisphere is equal to 2 pi r square. Substituting these values of areas and simplifying, we get total surface area of the wooden object as equal to 2 pi r into h plus 2r. Let us consider this as equation 1. Substituting the given values of r and h in equation 1, and on simplification, we get total surface area of the wooden article is equal to 594 centimeters square. Now, let us solve a real-life problem of finding the surface area of the decorative block to be painted. A decorative block is made up of two solids, a cube and a hemisphere. The base of the block is the edge of 7 centimeters and the hemisphere on the top has a diameter of 4.9 centimeters. If the block is to be painted, find the total area to be painted. The decorative block is made up of two solids, a cube and a hemisphere. Part of the cube where the hemisphere is attached is not available for painting. It is given that the cube has an edge of 7 centimeters. The diameter of hemisphere is 4.9 centimeters. So the radius of hemisphere, which is half the diameter, is equal to 2.45 centimeters. So the area of the block to be painted is equal to the sum of the total surface area of cube and the curved surface area of hemisphere, excluding the base area of the hemisphere. Let us take this as equation 1.
What is the total surface area of cube?
We know total surface area of the cube is equal to 6a square. Substituting the values and simplifying, we get total surface area of the cube is equal to 294 centimeters square. We know that the curved surface area of hemisphere is 2 pi r square, and the base area of the hemisphere is equal to the area of the circle, which is equal to pi r square. Substituting the known values and simplifying, we get curved surface area of hemisphere is equal to 37.73 centimeters square and its base area as equal to 18.865 centimeters square. Now, substituting the computed values of areas in equation 1, we get total area of the decorative block to be painted as equal to 312.86 centimeters square.